Hello. I'm just going to be talking about WebSockets today. There may be a technology that you might have heard about here and there, but you might not have actually thought about, like, how could we get this implemented in our app, in our stack. So I'm here to talk about that. It's a spec that's been around since 2010. I think it's getting quite stable now, and it's really useful for a few things. So I just want to kind of see. I just want to give you like an introduction to WebSockets. So a bit about me. I'm Micheal. I do a bit of work on Coffee, which is co-maintained by me and someone else. It mainly works with chat protocols, so it's kind of a way of abstracting multiple different chat protocols into one sort of unified API. I'm a moderator of our NPM, which is an unofficial NPM subreddit. And there's my website and my Twitter handle, which is also conveniently my GitHub handle. So, yeah. I work at iResources. I'm a junior developer. I work on mainly I work on our built in-house app, which is Neatly.io. And there's a website and Twitter handles there. And one reason why I came to do WebSockets today is because WebSockets could be very sort of beneficial to our stack, and it's kind of could be very, very beneficial to one of your stack. So let's go over some examples and just relative support for WebSockets. We can see that this is how you would make a WebSocket server. So it attaches itself to the HTTP library, which Joe just talked about. And essentially what we're doing is we are creating a server. We're attaching it to Express because I've always ever attached it to Express. And what we're doing is we're saying, use this server, and on the request, send that to the on the server request, send it to the app, and then listen on port 3000 if an environment variable called port isn't set already. And then the client-side code, you can see that we're defining a variable called WLS. We're making a new WebSocket. This is pretty standardized way of making a WebSocket connection. And we're defining where we want to make the WebSocket. It's important to note that we're using WLS as the sort of protocol. That's just how it is. And what we're doing is we're saying on open, we're going to log to the console. We are now connected to the WebSocket. When we're on when we get a message, we're going to just echo it out. So we're going to send it back through the WebSocket using WLS send. And then when we close, when it's on close, so that means if you've lost connection or it's terminated it on the server side, you're going to get the socket connection that's been closed. It's also triggered if you were to close it on the client side. So I just got this from Can I Use, formatted a bit. The top line is the latest versions without support, partial support in the second line, and then the ones that are fully supporting WebSockets in the third line. It's interesting to note that some of them just go from no support straight to full support. And mainly the partial support ones are ones that are using outdated WebSocket libraries, and they might be vulnerable to security flaws, and they might not have the full features. So, for example, Chrome might not have full binary transfer features in Chrome 15. So I'm just going to go about performance. They're quite performant, and it will help a ton if you use a lot of real-time stuff in your web app. And it can make a significant difference over long polling. So I've got a quote here from Ian Hickson, which is the leader of the HTML5 spec at Google. He also works at Google, sorry. And he says, reducing kilobytes of data to 2 bytes and reducing latency from 150 milliseconds to 50 milliseconds is far more than marginal. In fact, these two factors alone are enough to make WebSockets seriously interesting to Google. Funnily enough, I went to Google Analytics to see if their real-time API actually has WebSockets, and they don't yet, but I suppose this is something that they want to try and get implemented in the near future. It will save them quite a lot of bandwidth and give them quite a bit of speed. So just recapping what Joe went over in the last talk. This is how you would make a typical HTTP request using XHR. We send off our request to the server. So in this case, we're getting API apples. And then we're getting back a HTTP response saying, yes, this is OK, here's the data. HTTP is not designed for bidirectional communication. It was mainly meant to get one thing and get it back. So after we did this, we went, well, what could we do? We could use long polling. And what we're essentially doing there is we're sending a request and we're waiting until the server sends it back. The server can wait until some sort of event. It could wait until an asynchronous task has been done. It could be waiting for like the database to complete something. And it's pretty much summed up in that line. Polling is request data and receive data sometime. Doesn't know when it's going to send back data. You just know it's going to happen sometime. And in a way, it's kind of cheating the HTTP protocol to actually kind of do a bit more bidirectional communication. Unfortunately, you have to kind of say, I want some data when you have it. And then WebSockets are a step forward from this. So you request a connection and you use the connection. It's important to note that it uses a HTML handshake to initiate the request. So we say we want to make a request to WS, and then whatever URL your WebSocket is at. It'll return back with a 101, which is switching protocols. And when this happens, you know that you're going to be upgraded to a WebSocket. Usually there's some other headers that are sent with it to say that it's going to be upgraded to WebSocket specifically. And from there, you can send as many frames as you want from the server to the client, and then you can send as many frames as you want from the client to the server. And it's pretty much summed up down there. It uses HTTP for handshake, WebSocket protocol for everything else. So why would we use WebSockets over XHR? We've got one request versus many, so you've got to think of things like DNS overhead, the bandwidth that might be used in transferring tons of headers. If we have one request instead of 100 requests, we're going to be saving ourselves a considerable amount of bandwidth and quite a considerable amount of headaches. And as long as the WebSocket is connected, data can flow. Obviously, if the server has terminated the connection or you've lost connection, you can't send data. So that's an important thing to note. And it doesn't count towards the Chrome 6 simultaneous requests per origin limit. Although there is sometimes a browser limit. I think the case is Firefox. Firefox has a 200 limit on WebSockets globally. So you're probably thinking, how can I be assured that WebSockets alone can single-handedly save me network throughput and thus money and headaches when coming to choose service to deploy my platform on? Consider this case study. We run a website with a lot of users. Let's say we were running a website with 20,000 users. The website uses long polling to check the availability of users in chat. So it's a chat website. Think of Slack, except for Slack's considerably much more popular. The website's running slowly because of long polling, and you find that you throw money at the problem. You're getting more servers to try and handle this bandwidth throughput. And you want to consider WebSockets because, well, it might make a difference. So one few things to note when we're doing these calculations: the average header size of the endpoint that we're using with XHR is 600 bytes per request, and the average data size of that, the actual body of the response, is 10 bytes. So I went ahead and I actually did a few calculations. How I did it is at the bottom left if you want to see that when it's uploaded to the internet. But you can see that there's a massive difference in bandwidth throughput. 5,000 users, you will see pretty much almost 24 megs shaved off your bandwidth for 100 requests in 60 seconds. And then it gets even more exponential as you get further up. And then I thought, how many WebSocket connections would it take for me to get to the same level of bandwidth that 5,000 users using long polling would take? The answer's down there, but does anyone have an idea? Like maybe at the back? No random numbers being thrown over? The number that I found out is about 305,000 users it would take to get the same bandwidth throughput as 5,000 users using long polling, which is quite a bit more than just marginal. So I'm just going to highlight this bit that was in the quote. Reducing kilobytes of data to 2 bytes and reducing latency from 150 milliseconds to 50 milliseconds. That's essentially what we're doing with WebSockets. We are reducing the amount that we're putting through the network, and also we don't have to wait for the connection. We are reducing our latency and we're reducing our overhead. So security, I am aware that when WebSockets were first kind of proposed, people had a lot of security concerns, especially since these are quite useful, and HTTP's been around for quite a while, and it's kind of found ways to become more secure and for people to kind of harden up HTTP servers. Man-in-the-middle attack, much less likely with WebSockets when it's connected, because obviously if you wanted to man-in-the-middle attack a HTTP server, you would have to kind of drop in something in the middle, and you can only really do that while it's connected, while it's not connected. If you were to have a constant connection, it would be much harder to man in the middle. And that's essentially it. I think you could also try and reduce the sort of the security implications on HTTP by using TLS and SSL. It's also got subprotocol validation. So if you wanted to be quite paranoid and ensure that people can't just drop in another WebSocket and stuff like that, you can say, right, I'm going to request specifically a protocol of XMPP. Because initially, they wanted to make this so then you could put XMPP over HTTP or IRC over HTTP. And we have a header that we use called SEC, for short for security, WebSocket protocol header, which defines what protocols will be accepted by the server and also can be used to say what protocols you want to send. It's also got frame masking, which means that it's a bit harder to kind of pinpoint these are WebSocket frames. If you try and find a pattern, if you try to find a match for all these frames, it will be quite hard, and it also avoids against cache poisoning, which can be used to serve some pretty nasty stuff if you're protected by Vanish and stuff like that. And also, obviously, there's TLS. WLSS exists. It's kind of like HTTPS to HTTP. It's WebSockets over TLS. Enough said with that. So there's some considerations and pitfalls that we should consider when using WebSockets, and it's kind of true for any sort of JavaScript thing. And obviously the most common thing is that the clients actually need to implement the security features. I guess you can use something like Can I Use, or you could use some sort of library that goes above and beyond what the inbuilt WebSockets do. But again, you've got to be quite security conscious. You can't guarantee a certain level of security. And due to the WebSocket standards being around since 2008 or 2010, somewhere around that time, and there being very many revisions of this protocol, some browsers do have old implementations, and that was kind of in the compatibility table. There are some with maybe version 6 of the protocol, some with maybe version 4, and newer implementations might be lacking somewhat. Any questions? I know this was a little bit short.
It's more of a question of like graceful fallbacks. So short of using Socket.io, which provides that for you, but it ties you into using it on both client and server, do you know of any nice ways of feature detection for feature sockets, WebSockets? That's the beer talking.
Well, to start off with, I guess you can use Modernizer to make sure that WebSockets are supported in the browser, which will check for WebSockets in the scope. But then, other than that, I know that there are a few websites that use Flash as a fallback or long polling, because it's a bit evil with Flash, but it does do sockets connections no bother, and also with long polling, I think Slack might go back to long polling. Slack is a major thing that does WebSockets, but yeah, long polling can replace what WebSockets already do. Any more questions?
Are you using it in production? And if you are, what are you using it for?
I haven't actually used it in production yet. I might plan on introducing this at where I work, and we might see about like looking at what benefits we might gain out of it. I would happily use it in production. It's pretty stable. It's been around since a while. Google, I think, has got quite good backing on the protocol, because it's seriously, like in the quote, it's seriously they seriously want to use it, and they will be kind of helping aid its development and aid the spec in making it more secure and more performant. And I think that's one of the good reasons why you would use it in production.
So yeah, I've used it in production and used it for internal monitoring tools. So it's like because you don't have to worry about the security as much. You don't have to worry about clients implementing the right thing, basically, and then it's a nice place to introduce it, basically.
Yeah.
So a dashboard with like requests per second kind of thing, whatever.
Yeah, it's pretty good. Any more questions? Yeah.
Have you ever had to work with it across like load balancers or like AWS Elastic load balancers, anything like that? Because we try to do some work with it, but getting past the session persistence problems being quite difficult. I just wondered if you had any experience with that.
Yeah, I've heard around that this might be one of the main pitfalls again. I hadn't really included it in this, but I do hear that's one of the pitfalls, is in it won't work behind load balancers, and you probably want to find a way to protect your WebSocket server from any sort of like massive amounts of requests. I haven't personally tried it, but something that you would want to definitely look into. I think you could like mitigate any sort of attack on a WebSocket by kind of throwing a few more threads at Node. That's possible with the cluster module, so you might want to look into that. But again, I haven't really tried it through any sort of firewall like that.
Cool, thank you.